हेलो माय डियर मैकेनिकल चैंपियंस, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? हाउ इज योर वीकेंड गोइंग ऑन? माई सेल्फ चंद्रशेखर वेलकमिंग यू ऑल टू दिस ब्यूटिफुल सेशन ऑफ थर्मोडायनेमिक्स, दैट इज द न्यूमेरिकल प्रैक्टिस सेशन. सो क्या आप लोग तैयार हैं टू हैव द रिगरस प्रैक्टिस ऑन द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स एंड द सेकेंड लॉ ऑफ थर्मोडायनेमिक्स? So first of all, please do let me know if I am audible and visible to everyone so that we can start this wonderful session on time. Am I audible and visible to everyone? Please keep your pen, notebook and calculator because you are supposed to solve the questions. Even if you commit the mistake, it does not matter. But the more you practice, the more confidence you develop in the subject, in the concept. All right. So please do let me know if my audio and visual quality are fine or not. Shall we start? For those who are attending the session for the very first time, this is my quick, simple, short introduction. I am a mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared engineering services examination and worked in Steel Authority of India Limited for a couple of years and quite comfortable in these many areas of mechanical engineering, fluid mechanics, heat transfer, thermal as well as industrial engineering. Right? So we have already discussed the theoretical part, conceptual part on the first law of thermodynamics couple of days back, and yesterday we had a session on second law of thermodynamics. And today we will be practicing some wonderful numericals based on the first law, based on the second law, as well as based on the basic concepts of thermodynamics. There are around 12 questions in total in my session today. And try to observe how many questions you will be able to get the right answer to. Right? You can connect with me through the mail ID, that is chandra.shekhar@byju's.com, and you can connect with me or you can join me on the Telegram as well. Once you become part of my Telegram group, then you will be getting the PDF of this session also to the Telegram group. You will be getting the various sessions updates which we bring from time to time for your benefit, and you can also discuss your doubts through the Telegram group, right? So if you have not joined me yet on my Telegram channel, it is very important, it will be very beneficial if you become part of this Telegram group, that is Mechanical by Chandrasekhar, and the link is also mentioned at the bottom. Those who are here, I would like you to respond me through the comment section to mark your physical and mental presence. So if you are all ready to explore this session, please let me know yes or no if you are ready to solve some numericals based on the basic thermodynamics. And on 4th of June, that is tomorrow at 12 noon, we will be conducting the scholarship test, and based on your performance in the scholarship, you will be able to avail the discount in our various courses. So it is going to be important once you become the part of this scholarship test. One thing you will understand is your level of preparation among your competitors, and based on your performance, you will be entitled to get the scholarship also in our various paid courses. Right? And the link to register yourself for the scholarship test is already there in the description box. Alright, so let us start with the question number 1. The question number 1 is on your screen. Read the question very carefully and get me the answer. All are MCQs. All the questions are MCQs. Read the question and the options are mentioned on the screen. 20 kilojoule, minus 40 kilojoule, minus 80 or plus 40 kilojoule. Every one of you, please get me the answer. The question says a closed system. What is a closed system? when there is no mass transfer take place from the system to the surrounding or vice versa. That is the closed system undergoes a process from 1 to 2 for which the value of heat transfer Q1 to 2 and the value of work transfer W1 to 2 are given as 20 kilojoule and 50 kilojoule respectively. Now, if the system is returned to the state 1 back, it means the system is undergoing a thermodynamic cycle, and for the reverse process, the rate of the heat transfer is minus 10 kilojoule. What will be the work transfer in the process 2 to 1? So there are two different processes, 1 to 2 and the another process is 2 to 1. That is the thermodynamic cycle. We can call the process A to be the process 1 to 2 and the process B is the process 2 to 1. What is the answer? So can we say for a thermodynamic cycle, because the initial and final states are same, according to first law, for a thermodynamic cycle, net heat transfer is equal to net work transfer and all the parameter must be used with sign. So can we say Q1 to 2 plus Q2 to 1 is equal to W1 to 2 plus W2 to 1. This expression is valid for reversible as well as irreversible cycle. Yes, no one? Well done. Good, good, good. What about others? Very simple question. Q1 to 2 is given as, it is not the heat transfer rate, let me call it as capital Q. Q1 to 2 is given as plus 20. All the parameter must be used with sign, and W1 to 2 is given as plus 50. Sorry. W1 to 2 is given as W1 to 2 is given as plus 50 and Q2 to 1 is given as minus 10. The only unknown is W2 to 1. What is the value of W2 to 1? It will be minus 50 plus 10. Isn't it minus 40? It is minus 40. Option B is the right answer for this one. Let us proceed to the next one. Let us move to the next question. Question number 2. Question number 2 on your screen. Along a path 1, 2, 3, a system absorbs 100 kilojoule as the heat and performs 60 kilojoule of work. While along the another path 1, 4, 3, it means for both the paths initial and final states are same, the system performs 20 kilojoule of work. What will be the heat absorbed during the process 1, 4, 3? Your options are minus 140 kilojoule, minus 80 kilojoule, minus 40, or option D says plus 60 kilojoule. Get me the answer quickly and your time starts now. Yes, every one of you. Well done. So it is not a thermodynamic cycle. There are two processes, 1, 2, 3 and the another process is 1, 4, 3. So initial point is 1, final point is 3. So initial and final states are same. So do you agree delta U will be same? Delta U in change in internal energy is the point function, state function. So it is U3 minus U1, that remains constant. So for the process 1 to 3, if we apply the first law of thermodynamics, so we can say Q1 to 3 Q1 to 3 so we can say Q1 to 3 is equal to W1 to 3 plus delta U. Can you find out the value of delta U here? What is the value of delta U? Just hold on. Yes. Can you see? There are process 1, 2, 3 and there is another process 1, 4, 3. So if we write the first law of thermodynamics, first law, then we can say Q123 is equal to W123 plus delta U. What is the value of delta U? Q123 is given as the system absorbs 100 kilojoule. Heat added to the system is positive as heat and performs 60 kilojoule of work. Work done by the system is again positive plus delta U. So delta U will be equal to 100 minus 60, that is plus 40 kilojoule. Delta U will be plus 40, and for the another process 143, for the process 143 is equal to W143 plus delta U. Delta U is 40 kilojoule, and what is the system performs 20 kilojoule of work. Work is done by the system, so plus 20 is equal to Q143. So what is the heat transfer? That is plus 60 kilojoule, isn't it? The answer will be option D. Yes, no one? Well done. Let us move to the next one. Question number 3. The question number 3 says a gas is flowing through an insulated nozzle. What is the meaning of insulated nozzle? It means the heat transfer is equal to 0. If the inlet velocity of the gas is negligible, it means C1 is also 0. And there is an enthalpy drop of 45 kilojoule per kg. That is specific enthalpy. So H1 minus H2 is given 45 kilojoule per kg. The velocity of the gas leaving the nozzle is, we need to find out C2. Options are 100 meter per second, 200 meter per second, 300, or option D says 350 meter per second, and your time starts now. The question is to find out C2. The question is to find out the value of C2. Can you do it? Again, the question is from the first law of thermodynamics, but applied to a steady flow process, and the nozzle is not used for any type of work transfer. There is no work transfer in case of a nozzle. So if we apply the steady flow energy equation or the first law applied to the steady flow process, so we can say H1 specific enthalpy plus C1 square by 2 kinetic energy plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W per unit time, per unit mass. Potential energy is having no change. C1 is given as 0, Q is 0, W is equal to 0. So we can say C2 is equal to under root of 2 H1 minus H2. If you put all the parameter in their SI unit, then you will get the unknown in its SI unit. Yes or no? Well done. C2 is equal to under root of 2 H1 minus H2 is given as 45 into 10 to the power 3. If you do the calculation, then why I am writing 45 into 10 to the power 3? Because it is in kilojoule. So put all the parameter in their SI unit, you will get the answer. So it is under root of 90,000. So it is 300 meter per second. Option C is the right answer for this one. Good. Question number 4. The next one. In an adiabatic process, what is adiabatic process? Heat transfer is equal to 0. 5000 joule of work is performed on a system. The system returns to its original state while 1000 joule of heat is added. The work done during the non-adiabatic process, it is again about the thermodynamic cycle undergoing two processes. One is adiabatic, another one is non-adiabatic. Your options are plus 4000 joule, minus 4000, plus 6000, or minus 6000 joule. Yes, tell me the right answer for question number 4. Can you solve it? There are two processes. 1 to 2 is adiabatic, or A to B is adiabatic. The process is 1, let us say, and another process. So Q1 is equal to 0. The second one is non-adiabatic, that is process 2. So Q2 is not 0. So for a thermodynamic cycle undergone by a system, net heat transfer is equal to net work transfer. Why? Because change in internal energy will be 0. For a cycle, change in internal energy will be 0. So can we say Q1 plus Q2 will be equal to W1 plus W2? Q1 plus Q2 is equal to W1 plus W2. What is the answer? What is Q1? That is given as 0. Process 1 is adiabatic. 5000 joule of work is performed on a system. What does that mean? It means the work is done on the system, that is 5000. So it will be minus 5000. W1 is equal to minus 5000, isn't it? Because work done on the system is taken as negative. The system returns to its original state while 1000 joule of heat is added to the system. It means this is 1000. And what is the value of work done in the non-adiabatic process? It will be plus of 6000. You should take care of the signs. With sign, all the parameter must be used with sign. Yes, no one? Well done. Good, good, good. Let us proceed to the next one then. On 6th of June, that is on Tuesday at 7:30 p.m., there will be a workshop, free workshop conducted by Dheeraj sir. He will be talking about the tips and tricks to secure all India rank 100 in your upcoming GATE 2024 examination. You register yourself for this workshop and the link is already there in the description box. All right. Shall we proceed further? Question number 5. Ready for question number 5? Question number 5. Beautiful question. A gas contained in a cylinder is compressed. The work required for the compression is 5000 kilojoule. That is work done. During the process, heat interaction of 2000 kilojoule causes the surrounding to be heated. That is the heat transfer. The change in internal energy of the gas during the process is, it is a thermodynamic process, not a cycle. And your options are minus 7000 kilojoule. Option B says minus 3000 kilojoule. Option C is plus 3000 and option D says plus of 7000 kilojoule. Right? It is a closed system undergoing a process. It is a closed system because there is no mass transfer taking place across the system boundary. We need to find out the change in internal energy during this process. What are the answers? What is the answer for this one? If you guys are comfortable with the units as well as if you are comfortable with the sign, positive and negative sign, then you will be able to get the right answer. Otherwise, there is a fair possibility you might end up getting the mistake in this. So for a thermodynamic process, we can say first law. If we apply the first law to a process, reversible or irreversible, it does not matter. So we can say the heat transfer is equal to work transfer plus change in internal energy. So a gas is contained in a cylinder is compressed. The work required for compression work is negative. So it will be minus 5000. Compression work is negative, that is the work done on the system. Expansion work is positive, that is the work done by the system, right? During the process, heat interaction of 2000 kilojoule causes the surrounding to be heated. What does that mean? That means the heat is rejected from the system to the surrounding. For the system, the heat transfer is again negative. Plus change in internal energy. So delta U is simply 5000 minus 2000, that is plus of 3000 kilojoule. Option C. Well done, no one. Option C is the right answer for this one. Right? Let us move to the next one. Question number 6. A non-flow. What is the meaning of non-flow? It means closed system. There is no mass flow taking place across the system boundary. Quasi-static process, it means the reversible process. Quasi-static means almost static. which occurs with the minute changes, very small changes, very small gradients. That is called as quasi-static, almost static. We can call it as reversible process. Occurs for which the pressure varies with volume given by the expression where V is the volume. What is the work done when the volume changes from 2 meter cube to 6 meter cube? The answers are, the options are 16 into 10 to the power 5, 16.5 into 10 to the power 5 joule, 16 into 10 to the power 3, and the last option says 16.5 into 10 to the power 2 joule. Yes. What is the answer? बताइए. The best preparation for tomorrow is giving your best today. So don't think much about the future. You should give your 100% today, then your future will be beautiful. Your career will be beautiful. What is the answer to this one? Because it is a reversible process undergone by a closed system, so the work done is integration of PDV, area under PV curve. That is the area under PV curve projected. Hi Tejal, good morning, welcome. Area under PV curve projected on volume axis. So pressure is a function of volume given. So we need to do the integration, that is minus 3V plus 16. It is in bar. So we need to convert it into Pascal. Then only we will get the answer to be in joule. dV into 10 to the power 5. Then it will become joule. And the limit of V will be 2 to 6. Can you do it? What is the answer? 1 bar is equal to 10 to the power 5 Pascal. Are you guys aware? 1 bar is equal to 10 to the power 2 kilopascal. 1 bar is equal to 100 kilopascal, or it is 10 to the power 5 Pascal. So do the integration. So we can say minus 3, it will be V square by 2 plus 16V, and the limit will be 2 to 6 into 10 to the power 5 joule. What is the answer? What is the correct answer? We can say minus 3 by 2 into 6 square minus 2 square plus 16, 6 minus 2 into 10 to the power 5. (36 minus 4, 32) divide by 2. 16 into 3. So W is equal to minus 16 into 3 plus 16 into 4 into 10 to the power 5 joule. When the pressure is taken in Pascal and volume is taken in meter cube, then pressure into volume will become Pascal into meter cube, that is the joule. Pascal into meter cube will be joule. The unit becomes joule. So it will be 16 into 1 into 10 to the power 5 joule. That is the work done. That will be the work done. Option A is the right answer. Yes. No one. Paisal World. Well done. Good, good, good. Let us move to the next one. Question number 7. Let us move to the question number 7. There are 3 engines A, B and C operating on Carnot cycle. Uses the working substances argon, oxygen and air respectively. Which engine will have the higher efficiency? Which one of them will have higher efficiency? A, B, C, or all the engines will have same efficiency? What is the answer to this one? Quickly, let me know the answer. The learning can never be done without error and defect, without errors and mistakes. So you should be ready to accept the mistake. You should be open to do as many mistakes as possible in your practice sessions, so that you learn from your mistakes and you do not repeat them in your final actual examination. All right, because they are working on Carnot cycle. What is a Carnot cycle? Carnot cycle is totally reversible cycle. Carnot cycle is totally reversible. What is the meaning of totally reversible? It is internally as well as externally reversible. So according to Carnot principle, for a reversible cycle, thermal efficiency of a reversible cycle is a function of source and the sink temperatures only. It is independent of working fluid or the system. For a reversible cycle, the thermal efficiency is independent of the working fluid. That is the Carnot principle. Or we can say the thermal efficiency of any irreversible cycle is always less than the thermal efficiency of a reversible cycle. The Carnot cycle is having the maximum efficiency because all are working on the Carnot cycle, so they will have the same efficiency. Option D is the right answer. Yes, Arnab, well done. Paisal, good. No one, great. Question number 8. A Carnot cycle is having an efficiency of 0.75. If the temperature of high temperature reservoir is 720 degrees, 27 degrees Celsius, the high temperature reservoir is the source. What is the temperature of the low temperature reservoir? If let me call it as T1, and the question is to find out the value of T2, low temperature reservoir or the sink temperature. Options are 23 degrees Celsius, minus 23 degrees Celsius or 0 degrees Celsius, and finally it is 250 degrees Celsius. Yes, question number 8 on your screen. Can you find out the answer? You should have a look to this thing. It is a Carnot cycle, it is a reversible cycle, and I said reversible cycle. For a reversible cycle, the efficiency is only dependent on the temperatures. If we draw a work producing thermodynamic cycle, it is a clockwise cycle. Q1 is heat supplied to the system, Q2 is the heat rejected from the system to the sink. The question is to find out T2. Can we say thermal efficiency for a cycle is the net work output upon heat supplied? And from the first law of thermodynamics, can we say W net is equal to Q1 minus Q2 upon Q1 from the first law of thermodynamics? So the thermal efficiency is 1 minus Q2 by Q1, and from the thermodynamic temperature scale, this is valid for reversible as well as irreversible cycle. It is valid for reversible as well as irreversible, and if the cycle is reversible, for a reversible cycle, we can say Q1 by T1 is equal to Q2 by T2, thermodynamic temperature scale. So we can say the thermal efficiency of the reversible cycle or the Carnot cycle is 1 minus T2 by T1. Thermal efficiency is 0.75, 1 minus T2 is unknown, T1 is 727 plus 273 Kelvin. Put all the temperature in there as in Kelvin, absolute temperature. So from here we can find out T2 as 1 minus 0.75 into 1000 Kelvin. So it will be 250 Kelvin. T2 is equal to 250 Kelvin. And if we want to convert it into degrees Celsius, then subtract 273. So this is minus 23 degrees Celsius. Yes or no? No one? Well done. Question. Answer to this question in degrees Celsius. The options are in degrees Celsius. Option B is the right answer for this one. Option B is the correct answer. And you should be aware that from 5th of June, from Monday onwards, we will be discussing the recent 5-year GATE questions for each and every subject. So it is going to be very, very important for all the GATE 2024 aspirants. you should know the pattern of the examination through the previous year question. So starting with 2019 to 2023 onwards, and on 5th of June, I will be starting the fluid mechanics at 11 a.m. Do join me on 5th of June at 11 a.m. for the fluid mechanics previous year questions discussion. All right. Do share this information to all your friends, colleagues, and do like this session also and share this session to all your friends and all your groups so that more and more people can join and get benefited. All right. Question number 9 on the screen. The COP, coefficient of performance, is used in case of heat pump or a refrigerator. When the cycle is a work consuming cycle, then we do not use the thermal efficiency, we use coefficient of performance. Of a heat pump and that of refrigerator are related as, options are COP of heat pump is COP of refrigerator plus 1, COP of heat pump is COP of refrigerator minus 1. The ratio of COP of heat pump and refrigerator is 1, and we can say COP for the heat pump is always less than COP for the refrigerator. Very simple question. That is for same input output. The relation is valid for same input and output. What is the answer? If we talk about, if we draw heat pump, this is Q1, this is Q2, this is work consuming cycle, this is the desired effect. And in case of refrigerator, this is Q2, this is Q1, the work input, this is the desired effect. In case of refrigerator, the desired effect is maintaining the lower temperature compared to the surrounding, and in case of heat pump, the objective is to maintain the higher temperature. So COP is given by desired effect upon net work input. That is the COP. So if we talk about refrigerator, then the desired output is Q2 upon W, and COP for a heat pump is equal to Q1 by W. That is the difference. So we can say COP for the heat pump minus COP for the refrigerator is equal to Q1 by W minus Q2 by W. So it will be Q1 minus Q2 by W. What is W? From the first law of thermodynamics, W can be written as Q1 minus Q2, that is equal to 1. So COP for heat pump minus COP for refrigerator is given as 1. So that is why the COP for the heat pump is 1 plus COP for the refrigerator. COP for the refrigerator can be less than, can be greater than 1, but coefficient of performance for a heat pump is always greater than 1. Option A will be the correct answer for question number 9. I hope this is clear. You all know about the relation between COP for the heat pump and the refrigerator. Question number 10. There is a heat pump working on a reverse Carnot cycle, has a COP of 5. Now, if it is working as a refrigerator, which is taking 1 kilowatt of work input, the refrigeration effect will be, your options are 1 kilowatt, 2 kilowatt, 3 kilowatt and 4 kilowatt. What is the refrigeration effect in case of refrigerator? If we talk about the refrigerator, it is anti-clockwise cycle, heat added from the desired output, maintaining the low temperature Q2, then this is Q1 and this is the ambient, that is T1. There is a work input. So refrigeration effect is the amount of heat which is to be abstracted from the storage space. This is the storage cold space. The amount of heat which need to be extracted from the cold storage space in order to maintain its lower temperature, right? COP for the heat pump is given. COP for the heat pump is given as 5. So can we find out the COP for the refrigerator for the same input and output conditions? If it would have been refrigerator, then it would have been 5 minus 1, that is equal to 4, isn't it? We have discussed previously COP of heat pump is equal to 1 plus COP for refrigerator. We can find out the COP for the refrigerator, that is 4, which is equal to Q2 upon W, that is the refrigeration effect. What is work input? That is 1 kilowatt. So Q2, that is equal to refrigeration effect, is equal to 4 into 1 kilowatt. The answer will be option D. D will be the answer for this one. Yes, no one, Arnav, well done. Every Saturday we are having two beautiful series. One is the Knowing the Legends and another is the Raftar series. So to make your learning more interesting, more fun, more joyful, we have brought these two beautiful, wonderful series. Raftar series is for the technology related to the automobile sector, and Knowing the Legends is all about the scientists, about their struggles, about their past, how they have invented or how they have developed the various laws of engineering. All right, let us move to question number 111, the second last question for the day. The question says the COP, it is also known as energy performing ratio, EPR, and as the COP increases, the performance increases. More will be the COP, more will be the performance. It is another performance parameter. It is the performance parameter for the work consuming cycles. For work producing cycles, efficiency, thermal efficiency is the performance parameter, but in case of work consuming cycles, it is EPR or COP, which decide the running cost of the device. More is the COP, less is the running cost. Less will be the power consumption. So the question says COP for a reversible refrigerator operating between two thermal reservoirs is 4. The efficiency in percentage of a reversible heat engine operating between the same temperature limits. Option says 10%, 20%, 30% and 40%. Arnav, there is no option containing 25%. No option is containing 25%. What is the answer to this one? Question number 11, second last question for you. Everyone, do you remember COP for a refrigerator is equal to Q2 by W? If it is a reversible refrigerator, then D2 upon T1 minus T2. If we talk about a reversible refrigerator, COP for a heat pump is given by Q1 by W, that is T1 upon T1 minus T2 if it is reversible heat pump, isn't it? And the thermal efficiency is given by W upon Q1. It is the reciprocal of COP for the heat pump, and if it is reversible, then it is T1 minus T2 upon T1. So if you observe them, then you can say thermal efficiency is the reciprocal of COP for the heat pump. So the relation is COP for a heat pump, which is equal to 1 plus COP for the refrigerator is equal to 1 upon thermal efficiency for a heat engine. So COP for a refrigerator is 4. If COP is 4, this is 4 plus 1. So we can say COP for the heat pump will be equal to 5. 5, isn't it? That is equal to 1 upon thermal efficiency. So the thermal efficiency is equal to 1 by 5 or 20%. The thermal efficiency of the engine will be 20%, 1 by 5. Yes or no? The answer is option B. B is the correct answer. And from my side, this is the last question for the session. A reverse Carnot cycle working as a heat pump has the COP of 7. What is the ratio minimum to maximum absolute temperatures? Your options are 7 by 8, 1 by 6, 6 by 7 or 1 by 7. 7 by 8 cannot be possible because It is about the ratio of minimum to maximum temperature. Oh, sorry, it can be 7 by 8 na. I thought it is 8 by 7. Yes. Minimum to maximum temperature for the reverse Carnot cycle working as a heat pump. This is Q1, this is Q2, this is W. This is the desired output. This is T1, this is T2. So the question is to find out T2 by T1. T2 is the lower temperature, T1 is the higher temperature. So the question is to find out. It is a reverse Carnot cycle. It means it is reversible cycle, work producing cycle. What is the answer? Your time starts now. Question number 12. Yes, can you get me the answer quickly? For a heat pump, COP is given by Q1 by W. It is given by Q1 by W, or we can say if it is a reversible heat pump, T1 upon T1 minus T2. That is given as 7. Or we can say T1 minus T2 by T1 is equal to 1 by 7. Isn't it 1 by 7? Or 1 minus T2 by T1 is equal to 1 by 7. So T2 by T1 is equal to 1 minus 1 by 7. That is 6 by 7 will be the answer. Option C is the right answer. The questions were simple but yet important for your competitive examination, right? So this is all from my side. I will bring more such session. Do not forget to join me on Monday at 11 a.m. for discussing GATE PYQ for fluid mechanics. All right. All the previous 5-year question will be discussed for the fluid mechanics in 3 sessions. FM1, FM2 and FM3. So Monday, Tuesday and Wednesday I will be there to discuss the previous 5-year questions from the fluid mechanics set 1 as well as set 2. All the questions from each and every set. All right. So this is all from my side. You can connect with me through the mail ID or you can join me on the Telegram also. So have a good day and a great weekend ahead. Thank you guys. Thank you for joining in. Take care. Let me take your leave now. See you on Monday at 11. Thank you guys. Thank you for joining in. Jai Hind.